This week we're moving on to life. We've been talking about science versus evolution in this class this quarter. We've talked about some foundational arguments. We looked at matter the last couple of weeks, and this week we're moving on to life. Let's start out easy. Life exists. Right? Anybody going to contest that point? Life exists. We good? We're on the same page. How did life get here? That's a bigger question. Regardless of whether you're an atheist or a Christian, life hasn't always existed. At one point, there was no life, whether that was, days 1 and 2 in the creation account, or for billions of years of evolution up until the point that life popped into existence. At one point, there was no life. Life hasn't always existed. So a reasonable question would be, can life scientifically pop into existence? Because if it can, then cool, why are we even talking about this? If it can't, well, that might pose some problems for our atheistic friends. Okay? Life popping into existence like this from a non-living substance is known as abiogenesis. That's a big word. Let's break it down. First of all, what does biogenesis mean?
Creation, generation.
Do what?
Creation of life.
Creation of life. So bio being life, genesis being origin. So the origin of life, where life came from. There is, conveniently for us, a law called the law of biogenesis. Anybody know what the law of biogenesis states? The law of biogenesis. No. Nobody?
They were homeschooled. I'm joking.
The law of biogenesis states that life always comes from pre-existing life of the same kind. Okay, this is a scientific law, and it tells us a couple of important things. Number one, every living thing is the offspring of at least one other living thing. And that offspring is always similar to the parent that it came from. Okay? There might be some minor differences, minor variations, depending on various genetic things in the reproduction cycle, but it will always be very similar. Come in, you're fine. It will always be very similar to that parent. And this leads us to an interesting dilemma. Because if every living thing is the offspring of at least one other living thing, then back that up. You're a living thing. You're the offspring of your parents. Your parents are the offspring of their parents. And so on and so forth. Back it up to the very first living thing. What is the very first living thing an offspring of? According to this, it would have to be another living thing, but we're at the very first living thing. So if the very first living thing has nothing before it, then it can't be the offspring of at least one other living thing. This law would have to have been broken. Okay? And that's what abiogenesis states. It's the idea that life can and did come from a non-living source, at least at the beginning. And again, this is actually true. Because regardless of your worldview, whether you're an atheist or a Christian, at one point there was no life. Now there is life. So at some point, there had to be this jump from non-life giving way to some sort of living being. But this fundamentally breaks that law. So my question is abiogenesis, which is true, is it consistent with the naturalistic atheistic assumption that we've been going with in this class? Now, for those of you who haven't been here, what do I mean by this? Some of you has been here. For those who haven't been here, what do I mean by the naturalistic atheistic assumption?
That everything that we experience today can be explained by what we see today.
Okay. Specifically, we're going with the naturalistic atheistic assumption that there is no God, there is nothing more than the material realm, so everything that we see today has to be explainable by the scientific laws that we observe today. That's the assumption that we're going with, and then we're looking at where that breaks. Okay? Does abiogenesis break our assumption? Fundamentally. Abiogenesis is true, but it breaks the law of biogenesis. Why, under the naturalistic atheistic assumption, why is breaking a scientific law bad?
Because that means it's not, observable by what we have. Or that was terrible.
No, again, yeah, it's not. It doesn't follow the scientific process that we observe. Can you, as something bound by the natural material universe, break a scientific law? No. To break a scientific law fundamentally requires something outside of the naturalistic universe, which breaks naturalistic atheism. So if we find a place where, say, the law of biogenesis is broken, that proves that naturalistic atheism cannot be true. If the law of biogenesis held true and was unbroken, life should not exist. Because abiogenesis happened at least once, what can we conclude specifically about those assumptions?
It's false.
They're false. They're wrong. Some atheists have tried to challenge the idea that the law of biogenesis is actually a scientific law. This is their main, this is one of the main ways that they try and get around this problem. That apparently if the law of biogenesis just wasn't a scientific law, it's okay, because then naturalistic atheism can still be true and abiogenesis had happened. You got something?
Not yet.
Okay. Shout it out when you do. It's okay. They've tried to get around this dilemma by challenging the idea that the law of biogenesis is a law. But it's a law for a very good reason. Okay, so we're going to look at the history of the law of biogenesis here for a second. It seems obvious to us now, but the law of biogenesis, the idea of living things only coming from other living things, wasn't always as obvious. Everyday life will tell us that if you leave meat out on the counter, it will develop maggots. Right? Milk left out grows all sorts of fun things. And for centuries, that was looked at as life just popping into existence. That is, of course, until some scientists came along and proved that completely wrong. And I'm, fair warning, going to butcher these names. I don't care. This is Lazzaro Spallanzani. We'll go with it. He conducted an experiment where he took some gravy and he boiled it. Okay? And the boiling of the gravy took out any potential life that was in the gravy. And he poured the gravy into two different bottles. One he left open, the other he corked, and it was completely sealed. What do you think happened? What do you think happened with the two gravies, with the gravy in the two bottles?
They both spoiled.
Eventually they would have both spoiled. One of them spoiled significantly faster.
One day.
The one that was open spoiled significantly faster. So the one that was sealed didn't seem to have life production. But maybe life just needs air to spontaneously generate. Okay. This is Francesco Redi. And he, in 1668, he took fresh meat. He put it into three different jars, apparently. One he left open, one he left sealed, and another he sealed with a fine netting. So the air could still get access to the meat, but nothing else could. What do you think happened? This is not a true question.
Well, the one with the fine netting would not produce maggots.
Correct.
The other one did.
The open one did.
But they both spoiled quickly.
To an extent, yeah. They both spoiled quickly. The one that was open would have had maggots. The one that was sealed with the netting would not have had maggots. And the one that was sealed wouldn't have had maggots and wouldn't have spoiled as bad. So we come to this dilemma here where food producing maggots seems to only work if there's air and seems to only work if there's not a netting covering it. Maybe it's just not consistent. Maybe life can just pop into existence, but it's not consistent. It's just random. So we can't really test it, right? Then we come to this guy, Louis Pasteur. Pasteurized milk, if you read that on a container, doesn't mean that they were just cows that were out in the field. It comes after this guy. In 1864, he created a very nutrient-rich broth. He then boiled that broth in this fancy little vessel with a curved neck. So the broth was here. He boiled this, and it had air access here and air access here. Actually, I think this was sealed, but it did have air access here. So in theory, whatever wanted access to the broth could have gotten access to the broth through this little long neck. But nothing could actually get there. Dust and microorganisms were caught in that curved neck. For over a year, he let this sit. And nothing grew. Over a year of just letting this sit open with access to air, nutrient-rich broth, this should be a breeding ground for life, nothing grew. Okay? He then broke off this section of it, letting anything have full direct access to the broth. What do you think happened?
Stuff started growing.
Stuff started growing within a day. After a year of not having anything grow, within a day stuff starts to grow. Unfortunately for the atheist, the law of biogenesis is a scientific law and should be classified as such. It is very consistent. Life only ever comes from pre-existing life of the same kind. They have to find some other way to explain away this question of abiogenesis. Okay? Their worldview is falling apart. They want to believe in atheism. They want that to be consistent, the naturalistic atheistic assumption. We want to give them, as we're approaching in this class, we're giving them the benefit of the doubt. We're assuming their worldview is true. We're seeing where stuff breaks. And it's breaking. This is evolutionary scientist J.D. Bernal, and he put it this way: it is possible to demonstrate effectively how life could not have arisen. The improbabilities are too great, the chances of the emergence of life are too small. Regrettably, from this point of view, life is here on Earth, and the arguments have to be bent around to support its existence. But nobody wants their worldview to fall apart. They're going to bend the arguments around, even when it doesn't make sense. They're going to try, despite no scientific evidence even indicating that spontaneous generation of life is possible, let alone that's how it happened, they're going to design experiments and try to bend the arguments around to make that a plausible theory. So we're going to look at them. We're going to look at their various attempts to make life from non-life, and we're going to see if it stacks up. The first one that we're going to look at is what I've titled spontaneous organization. In 2000, Gerard Wong, pictured on the screen, and several of his friends made a crazy discovery. They conducted an experiment, and they found that if you combined a few chemicals, a certain reaction will occur. The chemicals organize themselves into ribbon-like tubes. It's pretty cool. And the claim is that these structures, these ribbon-like tubes, resemble the three-layer structure in the cell of a bacterium. That's it. That's the crazy discovery that they made.
You could do that with like oil and water.
You could do that with oil and water. Is this an impactful discovery related to the origin of life?
No.
What did we really learn here?
That different viscosities create different levels of buoyancy within the cellular liquids.
Well,
It's a really complicated way of putting it, but I like it.
additionally, that somebody has to put the ingredients together to make the life.
That was wasted with what I said.
All we really learned here is the chemical reactions happened, which is way simpler than what you said.
Yeah.
It's what you said. Way
Shut up
simpler
now.
than what you said. It's okay. I like the complicated. All we really learned is that chemical reactions happen. Okay. Chemical reactions happen. This isn't groundbreaking news, right? Another problem is that all the ingredients were assumed. And we'll get to this in a few minutes, but that actually probably would not have been the case. The ingredients that were there to make the life form probably wouldn't have ever actually been there to make the life form. But they just assumed that all the ingredients were there and the chemical reactions happen and somehow that's supposed to prove life. The end result was also not life. We had chemicals organizing themselves in tubes. There's no DNA, there's no metabolic activity, there's no reproductive anything. There's nothing that scientists look for when they're trying to identify something as living.
No, go ahead.
Okay. There's nothing special about this spontaneous organization. There's nothing special about this experiment or the discoveries from it. We didn't really learn anything. Least of all, we didn't learn anything in the direction of life popping into existence out of nothing. This is Daniel Gibson, and he and some of his other scientific friends in 2010 claimed to have produced life from a bottle. They reportedly created life, in quotes, from 4 different chemicals. They replaced a chromosome in a bacterium cell with a chemically synthesized genome.
Hang on, they took life from life?
Yeah, and made life.
It made life.
Cool. Yeah. The functioning bacterium was then created, and it did actually work. The bacterium worked, but even with the synthetically, chemically synthesized genome, it all fused together and it worked. It was great, I guess. Was it created? I don't know that I would say that, but it worked. Is this an example of life coming from non-life? Not even a little bit, right? Everything that we've already talked about is still an issue. Okay? This isn't really life. Everything was already assumed. The chemical reactions happened, so what? They didn't really create the enzymes and the other structures needed for life. They were just already assumed to have been there and to be in the cell. This is not an example of life coming from non-life. But there's other issues with this one too. No DNA was created by natural processes. Only existing DNA was copied. In order for life to pop into existence out of nothing, you would have to find some way of getting DNA or the genetic code to be generated for the cell and natural processes to actually exist. And we're going to get into this next week and the week after when we talk about genetics, but that's not going to happen here. Okay, no new DNA was created, but new DNA would have to have been created at the beginning whenever life allegedly popped into existence. There's a difference between writing a doctoral thesis and copying and pasting a doctoral thesis and claiming it as your own. They took the existing DNA, the existing genetics for this bacterium, synthesized it, and then reinserted it into a bacterium, claiming that they had created something. They didn't. They plagiarized the DNA that was already there. This is not impressive. Third problem is that human intervention was actually required in this one. In order to make sure that the synthesized genome that they inserted actually took hold in the cell, they had to help that process along. It's not like they just threw the genome in a pile of chemicals and it just sort of gloped together and created a cell. They had to actually force it to happen. I don't know about what they're thinking, but when I'm thinking about the origin of life, I'm not thinking that humans are going to be there to intervene on this process. If human intervention is required in order to make this experiment work, this fundamentally can't tell us anything about where life came from.
And it represents God, because if we have a higher being that is able to manipulate the circumstances to create life, that is mirroring what God did.
It's almost like life is designed, and it looks like it, and it has to be that way.
Yeah.
You got something? We didn't really learn anything from this experiment either. We might try and learn something from this one. This one is probably the one that y'all are all familiar with. This is the Miller and Urey experiment, performed all the way back in 1953, and it's still the most prominent piece of evidence that they have. It's touted in science textbooks as if it were some amazing discovery. And even with how far science and the evolutionary theory have developed since the 50s, 53, since then, they've made no real progress beyond what we found here. Okay, so this is the slam dunk case for the origin of life from the atheistic perspective. They attempted to, under laboratory conditions, simulate the theoretical prebiotic Earth. Prebiotic just meaning before biology, so just chemical reactions, raw, unfiltered, what it was like before life existed. They mixed a variety of chemicals in a flask, and then they ran ultraviolet light electrical sparks through that flask. Okay? What do you think happened? If you're familiar with the experiment, what do you know happened? A lot of tar. There were a couple of simple amino acids, but a lot of tar. The end result was a lumpy, blob-like mixture of essentially a bunch of tar along with two simple amino acids. Is this life? Is this anywhere close to life? I see a lot of shaking heads, and that's good. Y'all have no clue how far away from life this actually is, and we're going to get into that here in just a second. It is at least a step in the right direction, because at least amino acids were formed here, right? This is the first example that we've actually looked at where something life-related, like amino acids, has come from some sort of non-living process or structure. Okay? But ironically, even though this is the most popular example of man-made life, it has the most problems with it. It's got all of the same problems that we've looked at for all of the previous experiments, such as they're assuming the ingredients, they're not really creating anything. Actually, life is just amino acids. It required human intervention. All the problems that we've already looked at still present in this one, but this one has several additional new issues. And it's funny, several new issues. There's going to be 4 of them, I think, that we're going to look at, and that's going to be on the next slide. As I was doing some additional reading last night on one of those points, I found a couple other scholarly articles that referenced another dozen additional problems that we're not going to be looking at. This thing is riddled with problems. If you're curious and you want to read a lot extra, I can send you several articles on just the problems with this experiment. We're nowhere close to making life in the lab, despite what they might claim. The first problem is that their hypothesized atmospheric conditions that they made in their lab are verifiably incorrect. They didn't have oxygen in their atmosphere. But not only do evolutionists now believe that the atmosphere of the prebiotic Earth would have actually contained oxygen, what makes it worse is the presence of that oxygen would have actually hindered life from popping into existence. The oxygen in the atmosphere would have oxidized any amino acids that did form, and it would have, in fact, prevented life from popping into existence. So the atmosphere that they were using to get these amino acids is wrong, and the atmosphere that we now think would have been in the prebiotic Earth would have stopped life from popping into existence entirely. Don't ask me how they're going to solve that issue. Second problem is that we have since learned that ultraviolet light is destructive to life and not beneficial. So even if, hypothetically, under the atmospheric conditions that they didn't use that would have actually prevented amino acids from forming, even if somehow miraculously amino acids did form, the ultraviolet light that they then used to make life would have actually killed it. Third problem is that the results of their experiment were just kind of silly, and that's a typo. That's supposed to say weird, or were, not we. That's hilarious. The results of the experiment were just kind of silly to begin with. Of everything that was produced from this experiment, most of it was completely unusable tar. In fact, the tar would have actually been hostile, toxic to the amino acids in the life that would have been produced. So the massive amounts of tar would have actually hindered the process as well. But the vast majority of the experiment was useless tar. Not life, not even really useful amino acids, which we'll get into. This is not really a success. This is, hey, we found a great way of making tar. And also a couple of amino acids. This is not life. If we look past all the tar, there were still only 2 simple amino acids produced. But that's 2 of the approximately 50 organic compounds on which life depends. So even if this was a roaring success, you would still have to have this experiment happen 25 more times in order to get the compounds that we need in order to make life. It's never going to happen.
And then make it duplicatable.
And then somehow make it duplicatable. And yeah, don't ask me the specifics on that. That's way over their head. They can't figure out how to get one experiment to go well. They're not going to figure out how to get it all to go well. The fourth issue is that the amino acids that they produced were actually the wrong kind of amino acid. We could take a rabbit hole on this. We're not going to. For the molecular biologists in the room, we're going to butcher some of this stuff. Don't at me, okay? Non-living molecules are always not chiral, which means that they're superimposable. Living molecules are always chiral, which means that they're not superimposable. Those are big words. What does that mean? So on here we have the not chiral side, which is the superimposable ones. You have the original molecule. You have the mirror image of the molecule, but you can rotate the original molecule to match the mirror image. Okay? That's not the case with the chiral molecule. Here you have the original molecule and you have the mirror image, and I don't care how much you rotate this thing, it's never going to match the mirror image. Okay? Non-living molecules are always this side. Living molecules are always this side.
Fascinating.
as a sort of side plot twist monkey wrench in the middle of all of this, there are two subcategories of this kind. And you can think of it as sort of left-handed and right-handed molecules on this side. Living molecules on this side are always left-handed. There's never any right-handed ones on this side that would then produce life. Okay? Guess which type of molecule was produced? Some of this one, but on this side, left and right-handed were also produced. And there's some fascinating additional reading that you could do with that, but even the presence of a single right-handed molecule on this side would have disrupted any sort of protein and DNA formation. If there was even one that wasn't left-handed and they tried to make a DNA helix out of it, it would have just fallen apart. So the fact that there was a mix of both means that even if this whole experiment was a roaring success, you still could have never gotten life out of it. That's it. That's their best evidence for life popping into existence out of nothing. Is it possible? Is it even remotely close? No. Even if everything else about this experiment were perfect, it would still not have done anything to show how life could have been produced from these amino acids. Like I said, that's their best evidence. But there's still more problems with life popping into existence. And this is where we get into the prebiotic Earth. Again, prebiotic meaning before there was life. Because life didn't just have to pop into existence and we didn't just have to recreate that in the lab. We have to figure out how. We still don't know how it would have happened in a lab, but let's assume for a moment that we did know how it happened in a lab. We would have had to figure out how that process could have been transferred from laboratory conditions to the prebiotic Earth, where there are no laboratory conditions, it's just the raw chemical reactions. Okay? Is that even possible? Well, that's what we're going to look at. This is James Tour. He's not the only person that we could look at here, but he is a very prominent one. He's wicked smart. If you ever listen to him talk, he talks over my head most of the time. This is from his website. This is his credentials. He's a synthetic organic chemist. He received his Bachelor of Science degree in chemistry from Syracuse University, his PhD in synthetic organic and organometallic chemistry from Purdue University, and his postdoctoral training in synthetic organic chemistry at the University of Wisconsin and Stanford University. He spent 11 years on the faculty of the Department of Chemistry and Biochemistry at the University of South Carolina. He joined the Center for Nanoscale Science and Technology at Rice University in '99, where he and is still today a professor of chemistry, a professor of computer science, and a professor of material science and nanoengineering. This guy is brilliant. He specializes in everything from nanoelectronics to lithium-ion batteries to splitting H2 and O2, which is a process you use in water purification, carbon composites, and all sorts of other stuff. This guy is a genius, okay? And he has specialized in non-biological chemistry. So if there's anybody that's going to know what a prebiotic Earth would look like, it'd be him. What has he found? Life needs many chemical compounds in order to exist. And the production of these compounds, even under laboratory conditions, is challenging, nigh on impossible. But even if we could get them to form using random chemical reactions, the evolutionary timeline assumes that the chemicals would then form and then just sit and wait around for all of the other necessary chemicals to form.
I think it's starting to make a lot more sense why the amount of time that they need for everything to happen just keeps increasing.
Keeps getting bigger.
Year.
But time actually works against them here. Because these chemicals are not very stable. These compounds that are needed for life are not very stable. So the fact that they would have to sit and wait around would actually mean that they would start to decompose. So even under the best case scenario, if we could get these chemicals to be produced in a prebiotic Earth, all of them would have to be produced at once and then immediately be used to create life. You couldn't have any of this, make one and then sit and wait and then make another, because by the time you would make all of them, the first few would have already started to decompose and deteriorate. So time is actually a deterrent here to life popping into existence. This kind of all of them popping into existence at once and then immediately forming life turns an already unrealistic event like life popping into existence out of nothing, into a laughable one. This would never happen, just statistically speaking.
Even if you could take a reaction and make a certain type of chemicals that you need to create life, and then this one over here, this one over here, you then have to organize them and then mix them together. That doesn't just magically happen by itself. Like that takes design and influence from the outside to even like get the individual ones taken. And if you have them too close together, the new chemical compounds would interact with and mess up the other ones. Like it does not work on so many different levels.
And you're right. And just to clarify, the laughable event, the statistically unlikely event that we're talking about, is literally just all of them popping into existence, not them producing life.
Right.
So the fact that you're saying that all of them have to organize themselves, that would be additional statistical improbabilities stacked on top of the laughable event of all of them being produced at once. It would never happen, but it has to under a prebiotic Earth. Ironically, though, beyond even those problems, the chemicals would never actually be produced. Take carbohydrates, for example. They're necessary for holding the DNA together, cell structure, energy consumption in the cell. They're responsible for a lot of things. You need carbohydrates in order to be alive. Even if somehow the chemical reactions that we're using could actually lead to making carbohydrates, the reactions wouldn't stop. As humans, we know to stop the reactions. If we're working under laboratory conditions, we start the reactions and we wait and we wait and we see a carbohydrate and we take the carbohydrate out. We know to stop the chemical reactions. The chemical reactions don't know to stop. And ironically, the chemical reactions that would have made the carbohydrate would have then immediately destroyed the carbohydrate, just because the chemical reactions would have kept continuing. You don't just need one type of carbohydrate. You need several. So not only would it never happen because the chemical reactions don't know when to stop, but it would have had to have happened several times. And you don't just need one type of chemical compound, you need several. There's 50 chemical compounds on which life depends. And you don't just need one little bit of each of these many types of chemical compounds, you need a bunch. Which leads us to our next issue. That not enough of the chemical compounds would actually be produced in these chemical reactions. For example, in our hypothetical carbohydrate situation, we would start the process somehow of combining all of these chemical compounds into life, and we would actually run out of carbohydrates before the life would be produced. Even if, hypothetically, one or all of the types could form, it still would run out before we would get to life. Even if they could sit around and last long enough to then produce life, they would still run out before we would actually get to life. In theory, then, the natural world would have to go back and create more compounds in order to finish making life from non-life. But that's silly. And this is why. This is James Tour again. It says that nature never kept a laboratory notebook. It doesn't know how to go back and create more chemicals. Even if it could make more, it has to start all over again, but it doesn't know how to start over again. It doesn't know why to start over again because it doesn't know what it's going towards. Nature would have run out of chemicals before life popped into existence. It would have had to have gone back and made more. But it couldn't. Even if it could hypothetically do it once, it's never going to do it enough. There's simply no plausible way for the prebiotic world using only raw chemical reactions to have ever produced life. This is Klaus Dose. This is the best picture I could find of him. He's an evolutionist. This is a quote from 1988, but it still holds true to this day. It says, more than 30 years of experimentation, so now more than, 88, that would be more than 60 years of experimentation on the origin of life in the fields of chemical and molecular evolution have led to a better perception of the immensity of the problem of the origin of life on Earth rather than to its solution. At present, all discussion on principal theories and experiments in the field either end in stalemate or in a confession of ignorance. So I'm going to ask the question again. Does it align? Given what we know about the law of biogenesis, and given our assumption of naturalistic atheism, are the two compatible at all?
You seen I was listening to Jeff Miller this week on Polishing the Pulpit. I've got all the lessons, but the thing now they're talking about is the multiverse.
Oh yeah, we covered that last week.
You did?
Yep.
So how we just happen to be in the one where life.
There's several
created.
different. Yeah, it's silliness. And part of the fun with this too, that's not a good word for it, the irony in it, is even if you could get past, say, the origin of life, you've still got a dozen other issues to look at. You've got where did matter come from, which their solution is the multiverse. You've got genetic impossibilities. You've got math improbabilities. Like, you've still got a dozen other issues. So even if you could say, okay, maybe an atheist could have enough faith to believe in spontaneous generation of life with the lack of evidence, they still have to believe all these other things. This is impossible. But it's not the only thing that's impossible. When you take all of atheism together scientifically, it's just impossibility after impossibility on top of a foundation of impossibilities. There's so much faith that's required to go into it. So like we hear the multiverse theory, and that's crazy, right? Who would in their right mind think the multiverse is an actual scientific solution? And you're right, it's still not the only issue.
Their arrogance and failure to believe in God, they'll assume and believe anything because they do not want to believe that there's a creator.
And again, we come back to the whole issue that we've been talking about all quarter thus far. It's a hard issue. We can logic through this all day, but it's a hard issue. They don't want to submit to God. They don't want to submit to a higher power. And I mean, to some extent, I kind of understand. I don't want to submit sometimes. But they so badly don't want to submit that they're willing to believe anything.
I also think about if you look at the distance of the planets, where Earth is from the sun, it's like if we were any farther away or any closer, it would be an issue. And it's not like there's not room for us to be farther or closer because of how the planets are distanced out. So the fact that Earth is right where it is, it's like,
It's almost like it was put there. I'm trying to remember if we're going to get to that or not. We're going to get to several of the fine-tuning issues in the math section as part of what we're covering. But yeah, is it distance? I'm trying to remember off the top of my head. I think it's angles. Like if we were like 0.1 degree in our orbit one way or another, like we would just cease to exist.
Yes.
Like it's...
pre-2
There's so much to this. And I'll say it like I've said almost every week so far. Your faith is well placed. This is not meant to puff you up. This is not meant to make you think, oh, we're so smart, we can go win every argument. This is not meant to be something with which you can bash people over the head and beat them down. We're trying to win souls. That's goal number 1. Goal number 2, don't listen to them when they say, hey, you're just unscientific as a Christian. Not only are you scientific as a Christian, but God has to exist. It's the only way to explain this. And as such, your faith is well placed.
They have no evidence.
They have no evidence.
They believe in something without all the evidence points to a creator.
All the evidence points to a creator. They believe in a lack of evidence while touting that they are only believing in the evidence.
Imagine the amount of faith that you would have, like just the sheer strength of your belief if you spent this much time and effort to build your faith, as they take to look for evidence which keeps returning as null.
And what a challenge to us. Are we putting this much effort into our faith? I'm not. Be real with y'all, I'm not. Like, this takes a lot of effort and a lot of research and a lot of faith to put into their beliefs. I believe that what I believe is true, and I study it, and I'm doing my best, but I'm fallible, obviously. They're so far beyond that, though. They're so dedicated to this.
Well, and as much as it's important to like put all of our effort into growing our faith and building our faith, at the same time, his yoke is easy and his burden is light, and we don't have to do somersaults to try to prove what we know to be true.
Yep.
I think it also kind of speaks maybe to if there are people who have certain abilities to really put in their all to their beliefs. So like someone like Paul, he was a religious zealot. He actively sought out to persecute those Christians. And I think it's that same spirit that he used to persecute those Christians that he used to be a Christian. And so it's just that level of seeking out, how can I put everything in this?
And what a wake-up call to us. This guy could be the next Paul. He's so devoted to his atheistic solution that he's going to believe anything. We can reach these people. And if we reach these people, imagine the level of dedication that they could bring to Christianity.
It's a pride issue. So it's going to be hard to reach someone like that.
Yeah.
Their arrogance.
Well, and to piggyback off evangelism this morning,
Go for it.
the parable of the master and the two servants, who the master forgave, which one will be more active? Which one is more thankful? The one that had such a debt, or the one that had less of a debt? Like, imagine how active one of these people would be in the church.
I can't even imagine that. Like,
I hope they keep looking because they're not going to find anything.
right.
So that's just proving the creation of belief more.
Whenever I see this level of ignorance, I think of the chief priests, because they literally sent people to stand by Jesus' tomb because they're like, oh, the disciples are going to take him away. And then he was still gone, and they were like, no, they still figured out something or something. And it's
Life
like,
spontaneously disappeared. Obviously.
Yeah. Any other
so
comments?
genetics is next week.
Genetics is next week. For the next 2 weeks, actually.
I have loved that, like, every single week you've taken a different piece of, like, what we hear is just common knowledge in the media of, like, oh, absolutely, this is accepted by everybody. And just looking at their own beliefs and their own logic, it is self-defeating every single time. And it's so refreshing to see, like, it clearly stated like this. It's very, very helpful.
Appreciate that.